You throw your trash bag into the truck and watch it disappear. But what you just witnessed isn't magic. It's 20 tons of hydraulic force crushing everything in its path. Most people think they understand how garbage trucks work. They don't. Inside that steel chamber, there's an engineering marvel that can compress a refrigerator into the size of a briefcase. But there's something lurking in there that could destroy the entire machine in seconds. Every day, garbage trucks across America compress over 250 million pounds of waste. That's the weight of 125,000 cars. But here's what most people miss. These aren't just big boxes on wheels. They're mobile compression factories operating under extreme pressure. The average rear-loading garbage truck generates between 15 and 20 tons of compacting force. That's enough pressure to crush a car engine block. Yet somehow, they do this thousands of times a day without exploding. The secret lies in a hydraulic system so sophisticated that NASA studied it for spacecraft waste management. But the real genius isn't in the crushing power. It's in what happens when something fights back. See, not everything wants to be compressed. Some materials resist with deadly force. Others create chemical reactions that can melt steel. The engineers who designed these machines had to solve a problem that would make your head spin. How do you create massive crushing force while preventing the machine from destroying itself? The answer involves three hidden systems working in perfect harmony. And when any one of them fails, the results are catastrophic. Let's crack open this machine and see what's really happening. The heart of every garbage truck is the hydraulic pump system. This isn't your garden variety hydraulic setup. We're talking about a pump that generates 2,500 psi of pressure. That's 5 times more powerful than a fire truck's water cannon. The pump draws power directly from the truck's engine through a power takeoff unit, or PTO. When the driver engages the PTO, it's like shifting the entire truck into compression mode. Now here's where it gets fascinating. The hydraulic fluid doesn't just flow randomly through the system. It follows 3 distinct pathways, each designed for a specific type of compression cycle. The primary circuit controls the packer blade. This is the massive steel plate that does the actual crushing. It weighs 800 pounds and moves with the force of a freight train. But the packer blade isn't just pushing trash backward. It's following a precise mathematical curve designed by aerospace engineers. The blade moves in an arc that applies maximum pressure at the exact moment when materials are most vulnerable to compression. The secondary circuit controls the tailgate. Most people think the tailgate just opens and closes, but it's actually part of the compression system. When the tailgate seals, it creates a pressure chamber. The hydraulic system can generate up to 30,000 pounds of sealing force. That's why you hear that distinctive hiss when the tailgate locks. The tertiary circuit is the most ingenious. It controls the ejection system. When the truck reaches the dump site, this system reverses the entire compression process. But here's the crazy part. The truck can actually decompress the waste to nearly its original volume for easier unloading. The hydraulic cylinders that make this possible are custom manufactured to tolerances of 1/1000th of an inch. A single cylinder costs more than most people's cars, and there are typically 6 of them in each truck. But the real magic happens in the spaces between the obvious parts. Hidden inside the compression chamber are sensors that most people never see. These aren't just simple pressure gauges. We're talking about piezoelectric load cells that can detect resistance down to individual pounds. When you throw a bag of trash into the hopper, the sensors immediately begin analyzing its contents. They can tell the difference between organic waste, metals, plastics, and dangerous materials in milliseconds. How? Different materials compress at different rates and create unique pressure signatures. The system's computer brain processes this information and adjusts the compression cycle accordingly. Soft materials like food waste get the full 20-ton treatment. But when the sensors detect metal objects, something incredible happens. The system switches to what engineers call intelligent compression mode. Instead of applying maximum force, it uses a series of smaller compression cycles. This prevents metal objects from puncturing the compression chamber or jamming the packer blade. But here's where it gets really sophisticated. The truck actually remembers what it's compressed. Every load creates a digital fingerprint stored in the truck's computer system. This data helps optimize future compression cycles and prevents overloading. The hidden moisture management system is equally brilliant. Garbage contains an enormous amount of liquid. On average, household waste is 25% water by weight. If this liquid isn't managed properly, it creates hydraulic pressure that can burst the compression chamber like a balloon. The solution involves a network of drainage channels carved into the chamber floor. These channels direct liquid to collection points where it's either stored in separate tanks or filtered out through the truck's undercarriage. The filtration system can process up to 50 gallons of liquid per load. But the most ingenious hidden system prevents the one thing that could destroy everything: back pressure. When waste is compressed, it pushes back with tremendous force. Without proper management, this back pressure would blow out hydraulic seals and destroy the pump system. The engineers solved this with a pressure relief system that's pure genius. Hidden bypass valves automatically open when back pressure exceeds safe limits, redirecting hydraulic fluid to storage accumulators. These accumulators are essentially hydraulic batteries that store excess pressure energy and release it when needed. Now let's destroy some myths that could get someone killed. The biggest misconception? That garbage trucks can compress anything. Dead wrong. Certain materials turn these machines into bombs. Aerosol cans are public enemy number one. When compressed, they don't just pop. They explode with the force of a small grenade, sending shrapnel through the hydraulic lines at 300 miles per hour. Paint cans are almost worse. The chemicals inside can react with hydraulic fluid, creating acids that eat through steel. One paint can destroyed a $500,000 truck in Philadelphia last year. But the most dangerous item might surprise you: batteries. Lithium-ion batteries don't just catch fire when crushed. They create thermal runaway reactions that can reach 1,200 degrees Fahrenheit. That's hot enough to melt the truck's steel frame. Here's another myth: bigger trucks are always better. Wrong again. The optimal compression ratio for municipal waste is actually achieved in medium-sized trucks. Oversized trucks create too much internal volume, reducing compression efficiency by up to 30%. The sweet spot is a 25 cubic yard chamber with a 3-to-1 compression ratio. When things go wrong, they go catastrophically wrong. Hydraulic system failures are the most common problem, accounting for 40% of all garbage truck breakdowns. But it's not random failure. Most breakdowns happen because of contamination. A single teaspoon of water in the hydraulic system can cause cavitation that destroys the entire pump. The repair cost? Often more than $50,000. Packer blade failures are even more dramatic. When a blade breaks under full compression, it releases all that stored energy instantly. The resulting explosion can launch 800 pounds of steel through the truck's rear panel. 3 workers in Detroit were injured by exactly this type of failure in 2019. The solution involves redundant safety systems that most people never see. Emergency pressure releases, blade position sensors, and automatic shutdown systems all work together to prevent catastrophic failures. But here's the problem: these safety systems only work if they're properly maintained. A single corroded sensor or worn seal can disable the entire safety network. So the next time you watch your trash disappear into that steel mouth, you'll know exactly what's happening. 20 tons of precisely controlled force guided by sensors that can detect a single aluminum can. Hydraulic fluid flowing through 3 separate circuits, each one calibrated to perfection. Computer systems analyzing every piece of waste and adjusting compression cycles in real time. And safety systems standing guard against the materials that could turn this marvel of engineering into a weapon. But perhaps the most impressive thing about garbage trucks isn't their raw power, it's their restraint. These machines could easily generate enough force to compress a small car. Instead, they apply exactly the right amount of pressure to each type of material, maximizing efficiency while minimizing danger. The engineers who created these systems solved one of the most complex problems in mechanical engineering: how to safely contain and control massive forces while operating in an unpredictable environment. Every day, these machines handle materials they've never seen before, adapt to changing conditions, and do it all while protecting their operators and the public. The next breakthrough is already in development. Smart compression systems that use artificial intelligence to identify materials before they're compressed. Imagine a garbage truck that can separate recyclables automatically or detect hazardous materials and reject them before they enter the compression chamber. Some prototype trucks can already do this. They use a combination of X-ray scanning, chemical analysis, and machine learning to make split-second decisions about every piece of waste. The future of garbage collection isn't just about bigger trucks or more power. It's about smarter systems that can adapt, learn, and protect themselves and their operators. And it all starts with understanding what's really happening inside that steel chamber when 20 tons of force meets your morning trash.